Experiment 3, we have worked on a digitalization and optimization of snow guards manufacturing process. There were 4 involved parties: Inomime as a supporting DIGITbrain, CAADEX as an end user basically working in the metal industry, Faculty of Science University of Kragujevac as a research and technology organization, and DSS as an independent software vendor. The main objective of the experiment was to implement an AI-based optimization engine to help and improve efficiency at the daily operation of the end user. The key was to achieve this aim is to identify and take care of pain points during the production process. At the end user side, there are 160 employees. It is operating in a disadvantaged NUTS2 region of Hungary. The company owns multiple complex machines with high cycle life. Mainly produces metal products for the construction industry. Amongst other, one division is dealing with roofing industry products. One of them is a snow guard machine. The machine itself is an OMS machine, which is used for creating more than 1,500 variants of guards at a total quantity 1.5 million kilograms per year. The machine is operated in 2 shifts. One shift can produce up to 13,000 pieces. The problem is that the switchover times between the variants can be up to 5 hours. During this time, no production is possible. The aim is to reduce the number and the length of these switchovers. The expectation of the experiment is that with the developed solution, the end user should be able to optimize the incoming orders into the right sequence so that they should avoid unnecessary switchovers. Moreover, they will be able to visually track and order during the whole life cycle, from its creation until the shipment and the final measurement evaluation. From the overall design, the solution consists of sensors installed to the machine, the IoT gateway which collects and transports the data to the database, from where it is transferred to the main application called OptiMaps running in the cloud. As a final step, a meta-based user interface is provided to inspect all the life cycle and visualize the data coming from the sensors. During the implementation, first, we have collected all the needs and requirements coming from the end user. We have designed a solution accordingly separated the different parts into the main modules. The development was done in multiple iterators, including cloud development with Kubernetes clusters. Then, we have rolled out the solution to the end user premises, where an intense testing phase was done. After the successful integration with the ERP system, we have installed sensors on the machines to measure the quantity of the products and vibration and temperature of the machine. A final testing phase was concluded at the end of these operations. We have successfully integrated the solution to the cloud broker and to the Amgora platform. Now, let's see the meta-based user interface to overview the actual production. The dark blue line represents the temperature. The orange represents the vibration of the machine. The light blue and the yellow line shows the expected and the real-time quantity of the product. We can see on the picture there were outages which need to be investigated afterwards. Switching to the OptiMaps user interface, we can overview orders coming from the ERP system, and we can see the machine calendar view, which visually represents the scheduled orders. By simply clicking the checkboxes at the beginning of the lines, the operator can start new optimization jobs. The result of this can be also observed in the machine calendar screen. There is also an option to see the daily schedule for a particular machine, even from the different shifts. As a result of the experiment, the end user has more optimal production process, which includes shorter lead times, also less storage capacity needed for warehousing. There is a reducement in production time and changeover times also. Overall, we expect a 20% reduction in downtime and 10% increase in productivity. Furthermore, the company expects to produce 1,000 orders and 200 products per year using the system. From the software provider view, an autonomous software is developed which can be easily used by sold to other companies operating in the same industry. Industrial exploitation of the software is underway. We are currently in discussions with about 10 companies about usage and pilot projects, and we expect to have between 20 and 30 by the end of the year.